Okay, hi guys. So this is our first lecture in this series. Okay, so in this lecture I will be talking about some of the reactions of alcohol and ether, or the hydrolysis of um, the ether group, which is in conjugation with the double bond. Okay, so after that we'll be starting off with elimination reactions in the subsequent lectures. So just continuing from there on. So let's suppose we have a reaction something like this. We have this compound and this is actually undergoing hydrolysis in acidic medium. So what actually happens in this reaction is um, what we actually get is this double bond actually attacks on this hydrogen atom, hydrogen ion, and what actually happens is this is the intermediate. Okay, and why is this intermediate stable? Because of the formation of our highly unstable um, conjugation of oxygen lone pairs with the positive charge. Hence this structure is stable because of the conjugation. Now what is the second step? The second step for this would be obviously H2O water molecules lone pair would be actually attacking on this positive charge, so and it will form something like this. Again H plus would be released, and how the H plus would be released? By this oxygen atom. Okay, so this would form our compound like this one. Now what will happen is, again this is our hemiacetal. If you look at closely, so hemiacetal is nothing but on the same carbon we have a ether group and we have a alcohol group. Okay, so now what will happen is, again this compound undergoes H plus addition of by hydrogen of hydrogen ion by the lone pairs on oxygen. So what actually happens is we get something like this, and CH3. Now what happens is this oxygen lone pairs actually forms a double bond with this carbon atom, and meanwhile this oxygen bond withdraws its bond with the neighboring C atom. Hence what happens is we have something like pH phenol formation and a aldehyde formation. Again this oxygen takes back its bond from hydrogen bond and form something like this with the release of H plus. Okay, so phenol and ethanol are the two products. Okay, so let us look into the second example. Second example, we have something like this. Okay, so what will happen if we place this compound in an acidic medium? So what will happen is this oxygen atom will actually attack on this H plus atom and will form something like this, ET and OET. Okay, so next what will happen is this hydrogen atom will take this bond away from the carbon atom, and that will result in a positive charge of this charge on this carbon atom and with the formation of ETOH. Okay, so now what will happen is, again positive bond or before that what will happen is the water molecule will actually the oxygen atom in the water molecule will actually donate its lone pair to the positively charged carbon atom here and form OH here with the release of again H plus, OH plus H plus. Okay, so now what will happen is this again in the H plus medium, this oxygen atom will actually attack on this H plus to form a positive bond here and a OH here with ETOH formed. Now again the lone pair electrons of oxygen atom will be donated to form a double bond here, and again H plus would be released. So this H plus consumed in this process would be released in the second step, hence this is formed. So the major product of this reaction is this one, ETOH. Okay, so now let's actually compare certain compounds in the order of their reaction, rate of reaction or hydrolysis in acidic medium for this one, second is this one, and third is simple with no double bond. Obviously the rate would be 1 is more than 2, which is more than 3. Why? Because in first, if you see, you'll get positive charge over here, as the hydrogen will be attached here from the acidic medium, and then we would have something like this. In second compound we would have a carbocation formation like this, and the third no addition reaction will even takes place. So third would be the last option, and that is natural. Okay, so for this carbocation you can have resonating structure with the lone pair conjugation with the positive charge here. Similarly I can do this for this carbocation, but in these two carbocations this has 6 alpha and this has only 3 alpha, hence this is more stable than second one. Okay, so let me write down some note here that unsaturated ether in which alkene and oxygen is in conjugation is highly reactive toward hydrolysis because of the formation of our this cation, and from now on we will be calling this cation as IIT cation because this is most stable cation, and questions related to this cation is asked so many times in JEE level competitive examinations. So I'll just write it that unsaturated ether in which alkene and oxygen is in conjugation is highly reactive towards hydrolysis, and because of the formation of our IIT cation. Okay, this is not a formal name, we are just using it for the name for the sake of fun and better understanding. Okay, and obviously acetal is highly reactive towards hydrolysis because of the formation of our again IIT cation, hence I'll just write it again. So acetal, which we just saw in our few minutes back, so acetal is highly reactive towards hydrolysis, and why? Because of the formation of our IIT cation. Okay, so at the end I just want to give a quick note that epoxide is actually highly reactive in all the mediums. Okay, whether it is acidic, whether it is basic, and what is the reason for it? The only reason that epoxide is highly reactive is because the 3-member ring is highly unstable because of high strain among all the atoms in the 3-member, as we have looked in our previous set of video lectures. So whether it's placed in acidic medium or whether it is placed in basic medium, in both the mediums it is highly reactive, and the product formed in acidic medium would be something like this, where CH2O18H would be formed here, and in basic medium obviously this would be the product formed, O18H on this on the middle carbon atom and CH2OH here. So I would want you to look at why these two products are formed when epoxide is placed in acidic medium and basic medium. I hope you get the answer, and this would be a homework problem for you. Okay, so with this note we end this lecture.